Okay, the last page. Yay! So, this is going to ask us, same thing, find f of g of x and g of f of x, and it's asking us if these functions are inverses. We can test to see if they are inverses um, if this is true, they are inverses if f of g of x is equal to x and g of f of x is equal to x. That's the only way they're going to be functions. Both have to be true. Both have to be true. So let's see if they are. F of g of x is equal to, so lots of x's in here. So let's take a look and see if this will, so let's take f of x. So it's a fraction. I have an x on top, then I have 2 plus another x. So g, we're going to plug in g every time we saw an x. So this is 2x over 1 minus x. And I have another x down here, so that's another 2x over 1 minus x. So now, in order to simplify, we are going to need to get these to be common denominators. So we're going to make this twice of that. Yep. So this is going to be equal to, this 2 is going to become 2, 1 minus x plus 2x all over 1 minus x. And that's a longer, there we go. So work in the denominator first, and you can bring over the numerator. So that's going to be 2x over 1 minus x. This looks like a hideous problem, right? But let's see what's going to happen. So then let's simplify. Let's work in the numerator of the denominator. And we can simplify that. We can distribute some stuff here. So this is going to be 2x over 1 minus x all over 2 times 1 is 2. 2 times negative x is a negative 2x. And then I have a positive 2x. And that's all over 1 minus x. So a negative 2x is going to cancel out with a positive 2x. And then because I'm dividing, I have a denominator here and a denominator here. They are both the same. Under division, that means they cancel out as well. Let me write that without these real quick. 2x over 1 minus x all over, so I have a 2 left over here, and a 1 minus x. If we do keep change flip, this takes this, that takes this right here, right? And it moves it up into the denominator. But it's the same as this right here, so they end up canceling out. They will cancel each other out. And then, so that would leave us with, and then this one would move up here. So they also would cancel each other out, leaving just x. Or if I did too much at the same time here, if I did too much at the same time here. Keep, change, flip would make this 2x times 1 minus x over 2 times 1 minus x. And so maybe now you can see easier that this 1 minus x cancels out that 1 minus x. That 2 cancels out that 2, leaving just x. So that works out. That works out. Okay. Next up. So let's need to do g of f of x. So we're going to take all of f and plug it into g. So I have 2 to the, plug in that whole big thing right there, over 1 minus that whole big thing again. And then we'll plug in f of x. So x, wrong color, x over 2 plus x. And this is 2x over 1 minus x. So let's take a look at this. Let's check the top here real quick. I can distribute that too. Yep. Hold on. 2. Did I do that right? Plug in. No, I gotta plug in f of x. This should say, messy, x over 2 plus x. Now, we can't just cancel out. Unfortunately, I can't just cancel out these two. And that's because there is a subtraction sign in here, which is unfortunate. Unfortunate. So we got to figure a way to get rid of that subtraction sign. So we can make this, we're going to change 1 to have a common denominator with 2 plus x. So this will be 2 plus x over 2 plus x. Okay, so that way we can combine these fractions. So, and then I'm also going to distribute that in here. So 2 times x over 2 plus x is 2x over 2 plus x, all over, well, this one's becoming this right here, so 2 plus x plus x plus x, all over 2 plus x. Okay. So just like what happened before up here, this denominator right here and this denominator right here, they are exactly the same, and because it's division, actually this would actually go up here, they would cancel each other out with keep, change, flip. They would cancel each other out with keep, change, flip. So that leaves us with 2x over 2 plus 2x. Scratch that. I lost my negative somewhere along the way. This should be 2 plus x minus x. So this guy right here should be a negative. So my 2 plus x minus x, those x's end up canceling out. So you should get 2x over 2, which is, obviously those cancel out, which is equal to x. So this is true, that is true. Thus, so F and G are inverses. F and G are inverses. Great. Great. Now, this next one. If you look, this next one is very similar to the one before it. So you can tell that we're using x over 2 plus x, 2x over 1 minus x, because whoever created this forgot to change that when he was copying and pasting and using placeholders. So it's exactly the same as that over there. Yay. Okay, the SAT question. The SAT question. This is a really good SAT question, I think. Some SAT questions are awful. I really like this one. It uses a bunch of different skills, and they all fit within this unit of Algebra 2, or Advanced Algebra. So let's look at 8x over 2 to the y. Now, I really want you guys to maybe take a look at this and see if you can't solve it on your own. Just to give yourself some practice, but these are the type of SAT questions you will see, and I really like this one. When you're looking at these, the best thing you want to do is try and get them to a common base. Whenever you have exponents, try and get things to a common base, and we can get 8 and 2 to a common base. This is going to be 2 to the third x over 2 to the y. And then we can do this bit right here where we just say 2 to the 3x over 2 to the y. I'm fairly confident most of you guys can get to here. So the next step is you just got to play around with it. Now, we don't know what this is equal to right now at all. We don't know what that's equal to. So there's no like multiplying to both sides. There's no taking the logs of both sides. We can't do all of that because we don't have an equivalent expression to compare it to. So we gotta maybe rearrange some things here. So we gotta use some of our properties to just sort of rearrange until something becomes familiar. Something comes familiar. So I don't know. Let's try trying to think of some different properties. I mean, the only property I can really think of is what if we put them all in a line here? So let's get rid of the fraction part and say 2 to the 3x times 2 to the negative y. So these are common bases, so now I can merge these two together. So I just add these exponents, 2 to the 3x minus y. And then I can look at this and think, wait a minute. 3x minus y is in our problem that we're given. We know exactly what 3x minus y is. So we can change 3x minus y to 12. Because 3x minus y is equal to 12, so we can just substitute that right in. So we know that this is equal to 2 to the 12th power. You don't need a calculator, leave it as that. That's probably an easier answer to read, 2 to the 12th, than actually multiplying 2 out 12 times. That's one way you can do it. That is one way you can do it. Some other students already solved it on their own. Trying to think of the way they solved it. They did the same thing. Like they got to 2 to the 3x over 2 to the y. And I think they rearranged some stuff here, and they knew that, what did they say? They said that y is equal to 3x minus 12. Is that what they did? 3x minus 12. So they substituted that in. 2 to the 3 to the x over y, 2 to the 3x minus 12. And then they used exponent rules again to bring this whole thing up. So they did 2 to the 3x times 2 to the negative 3x plus 12, since we have to change the sign to get it out of the numerator. And when they added them, those canceled out, giving them 2 to the 12th power. That is also a totally valid process. Totally valid process. Okay, now the super fun, annoying, yet oddly satisfying question. Simplify this without a calculator. Without a calculator. So if I'm ever asking you to not use a calculator, it's either going to give an exact answer or it's going to work out really cleanly. Really cleanly. So here's what I'm going to do. I'm going to start this problem, but I want you guys to figure out the next step. So we start by giving them all to a common log. So find the common log. So we just change a base formula. So it doesn't matter what log you use. You can use ln, you can use log, just whatever. So I'm going to use ln because I can save more room that way. It's easier to write the 2 letters than the 3 if you're going to do it a bunch. So this is going to be ln of 7 over ln of 4. That right there is my first log. Change of base formula. The 7 goes in the numerator. The 4 goes in the denominator. Times ln of 4 over ln of 12 times ln of 5 over ln of 7 times ln of 12 over ln of 5. And I don't actually need to change the base of this one. So this is just ln of e. So that's the change of base formula. Find the next step, simplify it as best you can, and then let me know what the answer is. I will see you guys tomorrow in class. Hope these videos were helpful.